Hi guys, welcome to this page of the notes, and we're just going to continue with this theme of solving natural base exponential equations and the natural base logarithmic equations, ln. So here we go. I've got a natural base e logarithm, ln, and I got to solve for x. Well, the first thing I'm going to do is take care of the multiplication division, so the 5 will get divided to the other side. ln of 6x is going to be equal to 8/5, right? Now, I got to get that x by itself, and so snail method is going to get us so that I have a base e exponential, e to the 8/5 power, I'll put it in parentheses, is all equal to 6x. Get that x by itself, e raised to the 8/5 power, all divided by 6. Again, you can throw that into your calculator. It's going to be second ln, the second function ln. Put 8/5, put it in parentheses so your calculator doesn't mess up the order of operations. Hit enter, divide by 6, and you should get 0.825 or something right around there if you round maybe slightly differently than I did. Hey, let's do an inequality. I now have a natural base logarithmic function, which is ln. And it's an inequality. Oh, and please be very careful. Remember, we had two different properties for inequalities when it came to logarithms. We had one where the logarithm was less than, and we had one where the logarithm was greater than. And we needed those two properties for this reason. Remember, you cannot take the logarithm of 0 or a negative number. We're going to have to watch out for that. So here we go. Let's go ahead and take care of this guy. And here's the way it's going to work. I've got my argument raised to the 4th power, so I'll just use that power property of logarithms to bring that 4 down out front. And so I wind up with 4 times the ln of x minus 8 is less than 4. Divide the 4 to the other side. ln of x minus 8 is less than 1. All right, at this point, I'm going to then use the snail method to rewrite this guy so that I have the natural base e raised to the 1st power and again, be very, very careful. Remember the way this works. You should remember this from the previous section when we talked about it. If not, go back and review that section or just pay attention here. It looks like I flipped the inequality, but please remember when you're solving these logarithmic inequalities, I actually didn't flip the inequality. Please notice that x minus 8 is less than, right? So when you use the snail method to rewrite it, you need to make sure that the x minus 8 stays less than. What happened is the x minus 8 was on the left of the inequality. Now the x minus 8 is on the right-hand side of the inequality. So even though it looks like I flipped my inequality, I actually did not flip it. X minus 8 is less than, x minus 8 is still less than. Please be very, very careful there that you don't accidentally flip your inequality, all right? Make sure that your inequality follows all the way through your problem. Now all I need to do to get that x by itself is add 8 to the other side. And so what I wind up with is x is less than e to the 1st plus 8. Well, you can do that on a calculator. E to the 1st power plus 8, I get approximately 10.72. But now I need to be very, very careful. Remember, here, I'll just draw you guys a quick little number line just to help you guys remember what this looks like. Let's see, let's call that 10. There's 11. And then down here, let's go, let's see, I need 10, 9, 8, 7, 6, 5, 4. All right, so there's my number line. Now, what I just found is x needs to be strictly less than 10.72. You don't have to be perfect. It's somewhere right about in there. We'll call that close enough. And I know that I need to be everything less than that. But remember, you've got to be really, really careful here, right? Because what could eventually happen when I get down here to some of these smaller numbers is I could wind up with a 0 or a negative number in here, right? And I can't take the ln of 0 or a negative number. And so what I've got to do is restrict my domain. And remember, the way that we should restrict our domain, just let me make myself a little dotted space over here for a little bit of side work. I just need to make sure that my argument, x minus 8, is always greater than 0. So switch my color here. X minus 8 needs to be greater than 0, right? I need this number to stay positive, and it can't even be 0. It's got to be a number bigger than 0. Now we go ahead and solve this guy, and we get x needs to be greater than 8. So there we go. I'm going to put an open circle on 8, and my inequality is everything less than 10.72 and everything greater than 8. If I pick a number less than 8, I'm going to wind up with something over here that I shouldn't get. All right, let's go ahead and do another inequality. This one we don't even have to worry about, right? Because this guy's always going to be bigger than 6, so I don't ever have to worry about it being negative or 0. So we'll just go ahead and solve this one and be done with it. I bring the 3 power property, bring the 3 down out front. Divide the 3 to the other side. Snail method. Snail method allows me to rewrite it. It'll be e to the 2nd power. I'll hold off on the inequality for a second just to make sure I don't make a mistake. E to the 2nd power, come around the inequality to the 2x minus 3. Now what I need to do is make sure that I don't flip my inequality. 2x minus 3 is greater than, so down here, 2x minus 3 needs to still be greater than. Right, so there we go. Now I got to get the x by itself. Add 3 to the other side. Divide both sides by 2. X is greater than e to the 2nd power plus 3, all divided by 2. And again, you can go ahead and put that into your calculator, and if you do, we get x is greater than 5.19. And again, here's the reason why that is not a problem at all. Negative 1, 0, 1, 2, 3, 4, we'll say 5 is up here, 6, 7, 8. Again, what this inequality tells me is I need everything bigger than 5.19, which is somewhere right around in there. And I'm everybody greater than that. Right? Because of the way that my inequality is pointing, I don't ever have to worry about winding up with 0 or a negative number in my logarithm, which obviously I can't take the logarithm of 0 or a negative number, but I don't have to worry about finding a lower restriction on my domain, because there's no way that this could ever give me 0 or a negative number in my logarithm. As opposed to this one up here, where because my value of x is less than 10.72, now I have to worry about finding a lower bound to restrict my domain, right? In this case, it turned out to be 8. So just be very wary of, right, when your logarithm is less than versus this problem where your logarithm is greater than. It's 2 different properties, and again, if you've forgotten how that works, just go back and rewatch the previous sections in this chapter. I go over all of that in a lot more detail in those sections. Head on over to the next page of the notes and we'll take a look at another problem involving logarithms. I'll meet you guys there.